Selamat sejahtera, very good afternoon to everyone. Okay, can I be heard loud and clear?
Yes, Doctor.
Okay, thank you. So today I will continue with this chapter on inventory management. I remember last week I've already discussed all the concepts with you. I've explained every single thing. I've also started to discuss a model, a mathematical model, which is called EOQ model, okay? EOQ model stands for Economic Order Quantity Model. If you remember this slide, there are several models that you will study. One of them is EOQ model, another is POQ model, and then we also have quantitative discount model, and also several more ones. There are several more to come, which is probabilistic model. Right, EOQ model, if you remember, the objective is to find the optimum order quantity. The optimum order quantity so that we can minimize the total cost. So it's basically if you have this total cost line, there is a minimum point. So this minimum point corresponds to the minimum total cost. So if we project to the x-axis, we get the optimum order quantity. And this optimum order quantity happens when the holding cost intersect with the setup cost. So in other words, it happens when the holding cost is equal to the setup cost. I've also explained to you how to calculate the setup cost. So setup cost is calculated using this formula, T divided by Q times S. P is the annual demand. Okay. Q is the number of quantity per order, and then times S. S is the setup or ordering cost for each order. Okay, I've also explained how to calculate the annual holding cost. It's just the average inventory level times the holding cost. So Q divided by 2 times H. And to find the optimum order quantity, okay, I already said it happens when the setup cost equals to the holding cost. So we have to equate. We have to equate means put it equal. We have to equate the setup cost as equal to the holding cost. And then we solve for Q. When we solve for Q, we get this. Q equals to square root 2 ds divided by H. So this is the formula to calculate the economic order quantity or the best order quantity that will give the minimum cost. And I think I stopped somewhere here last week. I've shown this example to you. Right, so today let me continue with EOQ model. So basically the EOQ model answers the how much question. So it means telling us what is the quantity to order. Every time when we want to place an order, what is the optimum quantity to order? Okay, that is the order quantity. Now, another issue that we have to know is when to order. Okay, when to order. So to answer this question, we have to calculate the reorder point. Reorder point is ROP. Reorder point tells us when to order. I have to explain very clearly to you. Please listen carefully. When to order doesn't refer to what time we have to order. It doesn't refer to the time. It refers to the inventory level or the inventory quantity that triggers the company to place an order. That is the reorder point. Reorder point is the inventory level or the inventory quantity that triggers a company to make an order. It's not the time when we order. So there is a formula to calculate reorder point. ROP equals to demand rate multiplied with lead time. So D is demand rate, normally calculated as demand per day. Demand per day. So D, demand per day, is calculated as capital D, capital K is the annual demand. The annual demand divided by the number of working days in a year. So if we use the annual demand divided by the number of working days in a year, we get the demand rate, which is demand per day. And L here is the lead time. What is lead time? I think I've already explained before. Lead time is the time between placing an order and receiving an order. The time between you place an order and the time between you receive the order. So that time duration is the lead time. It's the time between placing and receiving an order. So if we multiply demand rate with lead time, we will get reorder point. Now I'll explain this to you again using this graphic. Hopefully everyone will understand. So if you look at this graph, the y-axis is the inventory level, okay, or the inventory quantity. The x-axis is the time in terms of days. What is Q star? Q star is the optimum order quantity, the EOQ value, economic order quantity or the optimum order quantity that gives us the minimum cost. So imagine at the start, we start from here, we have nothing and the order is received. Okay, let's say from the start, we receive an order from the supplier. So when we receive the order, our stock level will go up until the order quantity level, because this is what we order, right? So we are at Q star now. So as time passes, the inventory will be used up, will be consumed. So it means the inventory level will decline. Okay, so this is the usage rate of the inventory. The inventory level will decline. And if you remember what I said last week, the usage rate that we assume in EOQ model is always constant and always linear. So therefore the slope of this line is constant. Okay, because the usage rate is constant. So the inventory level will decline until it reaches the zero level. Now, in practice, no company will wait until the inventory becomes zero and then only start to make an order. Alright, company will not wait until the inventory becomes zero and then only start calling the supplier and start making the order. Why? Because if the company starts to make the order at this point here, then it means the company will have to wait for several more days before the order arrives. Right, so when the order arrives, the stock will be replenished, it will go up again, and then it will consume it, so it will go down again, and the cycle will be repeated and repeated and repeated. So what I'm trying to say here is company will not order when the inventory has already reached zero level. It's too risky. Okay, because there is a time gap here where the company has no inventory. Right? If the company has no inventory, then the company cannot produce, cannot fulfill customer demand and may suffer a lot of losses. So what happened in practice is the company will have to reorder before the inventory level reaches the zero level. So it means the company will have to start placing the order, start calling the supplier to make order well before the inventory level becomes zero. Right? So to know when we have to reorder, we have to look at the lead time and work backwards. Remember what is lead time? This time is the time between placing an order and receiving an order. So if we start from this 0 point here, and if we work backwards based on the lead time, okay, let's say lead time is L. So let's say we work backwards from this 0 point, we work backwards L number of days, which is the lead time. And if we project to the graph, and then we project to the y-axis, we will get this value. This is actually the reorder point. Okay, so it means when the inventory level has reached this point here, the company should already start to make an order. Okay, because after L number of days, which is lead time, the order will arrive. And when the order arrives, the stock will be replenished. Okay, so it means if we start ordering at this point, after L number of days, or in other words, just after the inventory level has reaches the zero level, okay, the zero level here, then the new order will arrive and the inventory level will be replenished and will be top up. Alright, so please understand this value here is what we call the reorder point. It is the inventory level, as I said, that will trigger the company to start making an order. Right, understand, huh? So this value is lead time. So this X value here is lead time, which is L. Okay, and the slope of this line is actually the usage rate, right? Usage rate of the inventory. So usage rate is equals to the demand rate. Okay, demand rate is actually usage rate. Usage rate is actually demand rate, because if we demand the inventory, if we need the inventory, it means that we have to use it. So whenever textbook say demand rate, so basically it's actually usage rate. So the usage rate or demand rate is D. So if we use the slope D times L here, we'll get this value. As simple as that. Right? Y over X is the slope. So to get Y, just use the slope times the X. So D times L will give you the ROP value, which is the reorder point. So I hope that is clear. Huh? So let's look at one example. A very simple example. So let's say demand is given as 8,000 iPods per year, okay, or any products, okay, 8,000 units of product per year. I need to emphasize again, in EOQ model, demand must be annual demand, okay, must be per year. If it is not per year, for example, per month or per week, you have to convert it to per year. So the demand per year is 8,000 units. The company works 250 days per year. Lead time for orders is 3 working days, or it may take 4 working days. Okay, either 3 or 4 lah. So first thing, to calculate the reorder point, we must know the demand rate. The small letter D. So demand rate is equals to the annual demand, which is 8,000, divided by the number of working days in the year, 250. So 8,000 divided 250 will give us 32 units. Okay, and L is already given. L is the lead time, either 3 working days or 4 working days. So from there we can calculate reorder point. It's just D times L. So 32 times 3 days will be 96 units. If the lead time is 3 days, so the reorder point is 96 units. And if the lead time is 4 days, so 4 times 32 is equals to 128. So the reorder point is 122 units if the lead time is 4 days. Right, so any questions so far?
No, doctor.
No question? Okay, is everything clear for you?
Yes, doctor. Clear.
Okay, thank you. Okay, so that is all about EOQ that you have to know. So basically EOQ, you just have to know how to calculate the reorder point. You must know how to calculate the total cost, which is the setup cost plus the holding cost. Okay, setup cost is calculated using this formula. Holding cost is calculated using this formula. And you must also know how to calculate the EOQ value using this formula. Right, so yes, any question? I heard someone talking. Any question? Okay, no question. So I think someone accidentally opened his mic.
له سوري دي إذا كان غير تمام ما هنا أيوة بعده
اللي سم
لا 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 قل له رضا نفس الرسالة اللي جابوا لي على حسابي سووا له عمر قالوا له ديسبوت.
Okay, I already muted him. Okay. Alright, so let's continue with next model. Next model is called POQ model, which is production order quantity model, POQ model. Now, POQ model is different from EOQ model, okay, because POQ model involves the production of the inventory as well as the usage of the inventory. Right? So in POQ model, we are talking about a company that produces its own inventory, for example, raw material inventory. And at the same time, the company is also using that inventory, okay, to make its final product. Right? So it's different from EOQ model because in the EOQ model, company does not make its own inventory. In the EOQ model, the company purchase the inventory from a supplier. Okay, remember, I hope you remember EOQ model, the company purchases the inventory from a supplier. So when the raw material inventory arrives, the company will use it. So in the EOQ model, it only has the usage phase. It only involves the usage of the inventory. But in the POQ model, it's different because it involves both the production as well as the usage of the inventory. So POQ model is suitable for a company that produces its own inventory, for example, raw material inventory, and then uses it to make the final product. Okay, even if the company does not use it, the company may sell it. Okay, may sell the inventory that it has produced to some other companies. So this model is useful. It's used when the units are produced and sold simultaneously. Okay, so here I already said either the company will sell it or the company will use it to make the final product. So this model is useful when the units are produced as well as used or sold simultaneously. So if you look at the inventory cycle for this POQ model, so same thing, the y-axis is the inventory level, the x-axis is the time. So the inventory cycle will look something like this. Okay, in triangle pattern. So let's start from here. So at this point here, the company will start. Okay, will start to make the raw material. Okay, it will start to make the raw material. At the same time, the company will also consume the raw material because it will need the raw material to make the final product. So this phase here is where production and usage is taking place. Production of the inventory as well as the usage of the inventory is taking place. So once the production of the inventory reach a maximum level, let's say this level, then the production will stop. Yeah, the company will not make it anymore, and then after that, the company will only use it to make the final product. So this is where the company will only use it. So this is the usage, okay, the usage phase of the inventory. Now, as we use the inventory will decline, right? It will go down until it reaches a certain level. In this case, it will reach zero. So once it reaches zero, the company will have to start production again. Okay, so the company will have to start making back the raw material inventory. Okay, so the thing will go up again, the inventory level will go up again until it reaches the maximum level. Once the inventory level reaches the maximum level, the production will stop. And then after that, the company will only use that produced inventory, the inventory that has been produced to make the final product. So it means after that, the company will only use the inventory. So this is where you have the usage phase. Okay, and the cycle will repeat and repeat and repeat. Okay, understand? But what you have to remember is in this phase, it involves both production and usage. So in this phase, the company is making the raw material inventory as well as using the raw material inventory. Okay, it is only in this phase that there is no production, where the company is fully using the inventory being produced. So that is the cycle of the POQ model. So let's look at how we can calculate the cost, which is the holding cost, setup cost, as well as the optimum production order quantity. In EOQ, we calculated the EOQ model, the EOQ quantity. In POQ model, we will calculate the POQ quantity, which is the production order quantity. So the first thing is you must know how to calculate the annual inventory costs. Okay, so the way of calculating annual inventory cost, the concept is just like the EOQ model, where you use the average inventory level multiplied with the holding cost per unit per year. Okay, maybe before this I explain all the symbol first. Explain all the symbol first. Q is the number of pieces per order. Okay, but for POQ model, it's actually the number of units or the number of pieces per production. So have to be careful, okay? Because as I said, we don't order the inventory from the supplier, but we make or produce the raw material inventory in-house. So Q is the optimum quantity, or the number of quantity, okay, per production. Sorry, it's not the optimum, it's the number of quantity per production. So Q is the number of pieces or quantity or units per production. H is the holding cost, has to be always per unit and per year. If it is not per unit and per year, you must change it to per unit and per year. Okay, and T is the length of the production run in days. So if you look at here, this is T. T is the length of the production run in days. Okay, and P is the daily production rate, because the company is making the raw material inventory, so it has a daily production rate. And D is the daily demand or usage rate, because the company is using the inventory that is produced to make the final product. I already explained demand rate is actually the usage rate, because we demand something, we need something because we need to use it. So demand rate is actually usage rate. Okay, so if you understand this symbol, then let's look at how to calculate the annual inventory holding cost is equal to the average inventory level times holding cost per unit per year. So average inventory level can be calculated as this, maximum inventory level divided by 2. So it means we use this maximum inventory level here divided by 2. That will give us the average inventory level. Okay, but how to get the maximum inventory level? Maximum inventory level is equal to this, total produced during production run minus total used during production run. Right, so if you look at this graph, I explained to you how we get PT minus DT. So remember, in this phase, production and usage is taking place. Production of the inventory and usage of the inventory is taking place. So if we only consider production, okay, then the production rate may be something like this. Be something like this. Okay, so this is the production rate. But at the same time, the inventory is being used, so there's a usage rate. So the usage rate is actually negative because we are using it. So the usage rate may be something like this. Okay, got it. So if we use this production rate, this line, minus this usage rate line, this usage line, we will get this line in between here, this red color line. Okay, we use the production line, this line that I've drawn here, which is the production rate, minus the usage line, which represents the usage rate. This line minus this line will give us the rate line. So this rate line is actually the inventory rate. Okay, so production line, the slope is positive. The usage line, the slope is negative, because we are using it. So it get reduced and reduced and reduced. Therefore, the slope is negative. Right? So what is the value of this point here? This point here. Okay, this point. This point here is actually the slope of this line. So the slope of this line is what? Is the production rate, right? So it's actually the production rate, P, multiplied with T. So we get this point here. Okay, this point here. So this point is P times T here. And what is the value of this point here? It's actually the usage rate, which is the slope of this line. The usage rate, which is the slope of this line, which is D. So the value is actually D times T. Right? So if we use this point minus this point, we will get this point. Okay, so therefore the maximum inventory level is just the point above here minus the point below here, which is the PT minus DT. This is how we get this. Maximum inventory level is PT minus DT. So maximum inventory level is PT minus DT. Okay, and as I explained just now, the Q, the number of units produced is equals to P times T. Okay, I explained just now. Q is the total produced, which is P times T lah. So in other words, T is equals to Q per P, because Q is P times T, so T is Q per P. So if we substitute this into this equation, okay, so we will get P times Q per P minus D times Q per P. So if we rearrange this, we will get this formula as the maximum inventory level. And remember, the annual holding cost is equals to maximum inventory level divided by 2 times H. Right? So the maximum inventory level is this term here divided by 2. So divided by 2 times H. Okay, times H. So this is the formula to calculate the annual holding cost. Right, what about the annual setup cost? To calculate the annual setup cost, the formula is the same. The same as the EOQ model. It is just D per Q times S. Okay, so these are the two formulas to calculate the setup cost and also the holding cost. So to find the optimum production order quantity, the concept is the same. It only happens when the setup cost equals to the holding cost. Right? So if we equate the setup cost as equal to the holding cost, so if we put this as an equation where the setup cost equals to the holding cost, we can solve for Q. So solve for Q. Okay, I think you know how to do this. You solve for Q. Finally, you will get this. Right, so Q star here is the optimum production order quantity that will give us the minimum total cost. So it is square root of 2 ds divided by h and then 1 minus d per p. So it's different, different from the EOQ model, slightly different. Okay, the difference is in this term here. So let's look at one example. Simple example. So given the annual demand is 1000 units, remember capital D must be annual demand, must be per year, so it's 1000 units. S is what? S is the setup cost, or ordering cost. For EOQ it is the ordering cost. For POQ it is the setup cost. Okay, so S is either the ordering cost or setup cost. In this case, it's the setup cost. Setup cost per production. So it is $10 per production. H is the holding cost. Holding cost is 50 cents. or $0.5 per unit per year. So it has to be always per unit and per year. P is what? Production rate. P is the production rate, is 8 units per day, given D is 4 units per day. D is the demand rate or usage rate. So with all this information, we can easily calculate the POQ value. Okay, using this formula. So square root 2 times D, D is 1000, S is 10, H is 0.5, and then 1 minus D per P here, D is 4, P is 8. So if you calculate, you get this. Okay, it looks simple, right? Actually, it's very simple if you understand all the symbols and if you understand what I explained just now. Now, in this question, D is 4 units per day. Actually, D can be calculated also if you know the number of working days. Right? D is the demand rate, right? So if you know the number of working days, then it's just the annual demand divided by the number of working days. Annual demand is given as 1000. Okay, and the number of working days is 250. So 1000 divided 250 will give us 4. Therefore, the demand rate or usage rate is 4. Okay, it says here when annual data are used, the equation becomes, okay, it's the same equation. This is the same equation. Same. Okay, but it's just different in terms of D and P. Now, if you look at here, D is given as 8 units per day. So it's per day. D is 4 units per day, also per day. Okay, but sometimes the question may give you P as 8 units per year. Okay, or D as 4 units per year. So even if they are per year, the equations will be the same. So it doesn't matter whether P and D are per day or per year, the equation will be the same. So if you look at this equation, it's exactly the same. Okay, but we are using annual demand rate for D and annual production rate for P. So it's per year per year. Okay, it doesn't matter because the numerator, the units in the numerator will cancel off with the units in the denominator. So it doesn't matter because we are dividing, right? So the value in the or the units in the numerator will cancel off with the units in the denominator. Okay, so third model is discount quantity. Maybe I don't go to here first. Okay, maybe I'll go to here on Wednesday. For the time being, maybe I give you a question to do so that everyone can understand it better. So I have prepared this tutorial question. It's also uploaded in e-learning. Okay, later when you have solved it, you can share the answer in e-learning. Okay, so for the time being, for the class now, I give you 5 minutes. Okay, to read the question and then to calculate all this and tell me the answer later. So everyone have to do it. Later I will call names to make sure you are not sleeping. Okay, so start now. 5 minutes. So question 1 is for EOQ model. It's for the EOQ model. Okay, let's do the question together, but I will ask you one by one later. So, a computer manufacturer purchases 8,000 transistors every year as components in computers. So, what is it? What is this 8,000? It's the D, The annual demand is 8,000, So, D is 8,000. Okay, the company purchases it, means the company needs it, means the company demands it. So, the capital D, demand per year is 8,000. The unit cost for each transistor is $10, and the cost of carrying one transistor in inventory for a year is $3. So $3 is what? Okay, can I ask Julian? Julian, are you here? Okay, Julian, are you here? Can you answer me? $3 is what? Okay, Julian is not here. Okay, Khairil Ikwan? Okay, Khairil Ikwan say $3 is H, Okay, so the holding cost, which is the carrying cost, per unit per year is 3, so H is 3. Okay, and then it says the ordering cost is $30 per order. So $30 per order is what? S. S. Okay, I see S. Okay. S is 30. And then it says the company operates on a 200-day working year. Means every year it works 200 days. Okay. So let's look at the first one. Calculate the optimum order quantity. So in other words, the question asks you to calculate EOQ. EOQ is the economic order quantity, which is also the optimum order quantity. They will give us the minimum cost. So anyone can share answer EOQ? What is the value that you have calculated? Okay. Oh, you type 400, 400, 400, 400. Okay, so let's do it together. I think it's 400 also. So EOQ as the formula is equals to square root 2 multiplied with D multiplied with S divide H. Okay, so it's equals to square root 2 times 8,000 times S, which is 30. Okay, divide by H, which is 3. So 400, correct? Okay, 400. So you should get 400 if you use this formula and put everything correctly. So your Q is equals to 400. Any question? Anyone doesn't understand? Part A? Okay, if no, then go to part B. Expected number of orders placed each year. Okay, can I ask, I call name randomly, can I ask Muhammad Ifat?
Yes, Doctor.
Ya, B ada jawapan tak?
20.
20, okay, how you calculate 20?
8,000 divided by 400.
Okay, very good, thank you. So expected number of orders have to place each year, means number of orders that you have to make each year is equals to the total that you need, which is 8,000. Okay, but we need 8,000, but every time we only order 400, right? So it means we have to order how many times? So that's the meaning of question B. So it means 8,000 divide 400. So give us 20. So it means we have to order 20 times, or in other words, in 1 year, we have to order 20 orders. Okay, no question, huh? B. Okay, C. Expected time between orders. Okay, Nurul, are you there? Okay, nama penuh I tak tahu I just tengok daripada screen Webex, Nurul. Nurul, are you there? Not there, okay, next. Rangga. Rangga Taruna, are you there?
Yes, doctor.
Okay, good. So what is your answer for expected time between orders?
10 days,
10 days. How you calculate 10 days?
200 divided by 20.
Okay, very good. Thank you. Okay, the company works 200 days per year. Every year it has to order 20 times. You have to make 20 orders. So if we use 200 divide 20, you get 10, huh? So it means every 10 days we have to make one order lah. So that is the expected time between orders. Okay, question D. The reorder point, given that the lead time is 3 days. Okay, can I ask Kamun? Kamun, are you there?
Yes, doctor.
Okay, good. What is your answer for reorder point?
120.
Okay, correct. Okay, thank you. Well done. Okay, so reorder point, as I said, is equal to D times L. Small d multiplied with L. Small d, small d. Okay, how you get small d? How to calculate small d? Yeah, two ways. You can use 8,000, which is the annual demand, divide by 200 working days. That will give us the demand rate. Or you can calculate D as the order quantity, 400, divide by the expected time between orders, divide by 10. Alright, understand? Either 8,000 divided by 200 or 400 divided by 10. So which will give us 40 lah. So D is equal to 40. Okay, and lead time is given as 3, so it means D times L is 40 times 3 lah. So reorder point is 40 times 3, 220. Okay, anyone has problem understanding this? You should let me know. If you have, don't keep quiet. Okay, what it will look like if we put all this information into the inventory cycle, into the inventory graph. So we plot the inventory graph. Okay, plotting it now. So the y-axis is the inventory level. Inventory level of quantity. X-axis is the time. Time. So our order quantity is 400. So it means, let's say we start to receive the order from time 0. So once we order, we receive it, we get 400. So we have 400 here. Okay, so imagine we receive the order quantity, the optimal order quantity at time 0, so 400. So we start here. So as time passes, we will consume the inventory, right? So it will decline until it reaches 0. Okay, and of course, the new order will arrive, right? So when the order arrives, it will go up back 400, and after that we will use up the inventory again. The thing will decline. Okay, and the cycle will repeat Okay, it will repeat for 20 times. This cycle will repeat for 20 times because we have to make 20 orders per year, 20 times of order per year. Okay, and the expected time between order is 10 days, so it means 10 days. So it means it's 10 here. It's 10 here, 10 days, this is 20 days. Disappear. So 400, this value is 10, okay, because expected time between orders is 10 days. So for the next cycle, this will be 20 lah. Okay, and so forth. So reorder point, given that lead time is 3 days, so if lead time is 3 days, it means 7 days, on the day 7, we have to start to reorder already, because lead time is 3 days. So we project upwards and we project to the y-axis. This is the reorder point, which is 120. Okay, so it means when the inventory level drops to 120 units, we have to start to reorder. Okay, because order will take 3 days to arrive. So once the inventory drops to 0, means after 3 days has passed, the new order will arrive. And once it arrives, it will top up, it will replenish the stock, and it will become 400 back. Okay, so I hope everyone understand. Okay, what about this question? So anyone can tell me which model is this? Which model that the question belongs? POQ, Khairul said POQ. Okay, correct, it's a POQ model, because we talk about production. Okay, so the company has an annual demand rate of 1,000 units. So D is 1,000, capital D, 1,000. Okay, and it can produce it at an annual production rate of 2,000 units. Oh, no. Okay, correct, I'm confused. A manufacturing company has an annual demand rate of 1,000 units, so capital D is 1,000. Okay, small d can also be 1,000, because we are using per year, right? So small d is 1,000. It can produce it at an annual production rate of 2,000 units. So P is 2,000. Okay, small d is the demand rate. Small p is the production rate. Setup cost to produce material A is $10 per setup. So S is 10, And carrying cost for 1 unit, okay, for 1 year is $1, so means H is 1. So the question asks, what is the optimum quantity of material A to be produced each time? So use back this formula, this formula. So POQ equals to square root 2, 2D, D is 1,000, S is 10, okay, divided by H, which is 1, and then bracket 1 minus D per P, small d, which is 1,000, divided by small p, which is 2,000. Okay, anyone can give me the answer for this? Okay, Amiro said 200, Fatinato said 200, Muhammad Rizwan said 200. Okay, 200, I assume it's 200. So POQ value is equals to 200. Okay, so for those that have answered correctly, well done. It shows that you understand. The rest, I'm not sure. Okay, the rest I'm not sure. If you don't understand, then let me know. Okay, you can contact me personally. Right, so I think let's stop here. It's already 4:57. So we stop here, and then on Sunday I will continue with some of the other models. That include the quantity discount model and also some probabilistic model. Okay, any other question? Okay, if no, then goodbye and see you on Wednesday. Okay, so bye bye.
Thank you, Doctor.
Okay, bye.
Thank you, Doctor.
Thank you, Doctor.